Right, an object moves at a constant linear speed of 8 meters per second around a circle of radius 4.2 meters. How large of a central angle does it sweep out in 2.5 seconds? Okay, well, what were we given here? We were given the linear speed. One of our formulas for linear speed is that it's equal to the angular speed times the radius of the circle. Okay, and I chose angular speed because it has the formula for the angular speed is the angle that you've swept out, theta, divided by the amount of time. Okay, and so I want angular speed because it will involve my theta and allow me to find that central angle. But we have to start here from what we're given. Okay, we were given the linear speed is 8 meters per second. That's our v. We were given our radius r. Okay, so we can use those. 8 meters per second is equal to our angular speed times our radius, which was 4.2. I'm going to divide both sides by 4.2 to solve for my angular speed. Okay, so for my angular speed, I get about 1.905, and that's in radians per second. Now I'm going to take that over here. Okay, I know my angular speed now is 1.905 radians per second. I do not know what theta is. I do know the amount of time was 2.5 seconds. If I multiply by 2.5, okay, so you can think of this as when we found the angular speed, that's how far it goes each second. If you go for 2.5 seconds, you would multiply that by 2.5, which is what we're doing here. Sorry, I'm missing a decimal there. Okay, so 1.905 times 2.5. And we get 4.7625. Okay, you can simplify that a little more, round it off a bit more. Just depends on what they asked for. They didn't specify here. And of course, that is in radians. Better state that. Okay. An object moves at a constant linear speed of 12 feet per second around a circle of radius 2 feet. So there's our radius. Here is our v, our linear speed. Again, how large is the central angle? If it sweeps out over 4 seconds. If you want to pause and try this one on your own, that's a good idea, or if you want to just follow along. So again, we were given the linear speed, and we know that's equal to the angular speed times the radius of our circle. Our linear speed was 12 feet per second, and our radius was 2 feet. We divide both sides by 2 and find that our angular speed is covering 6 radians for each second. How much is swept out in 4 seconds? Well, 4 times 6. If you want a formula for that, remember that angular speed is equal to our angle theta divided by the amount of time. Okay, we know our angular speed is 6, we know theta, and our time is 4. Multiply both sides by 4, and we find that theta is equal to 24 radians are covered in 4 seconds.